So the various components which are used in suspension formulation already covered. Here, the list of suspending agents used for manufacturing suspensions like alginate methylcellulose, hydroxyethylcellulose, carboxymethylcellulose, sodium carboxymethylcellulose, microcrystalline cellulose, acacia, tragacanth, xanthan gum, bentonite, carbomar, carrageenan, powdered cellulose, gelatin. These are also these are all I have already discussed uh, in thickening agents like polysaccharides, natural polysaccharides, semi-synthetic polysaccharides, inorganic agents, and synthetic compounds. Okay, most suspending agents perform two functions. Therefore, besides acting as a suspending agents, they are also imparts viscosity to the solution. Suspending agents forms film around particles and decrease interparticle attraction. I have already told. A good suspension should have well-developed thixotrophy. At rest, the solution is sufficient viscous to prevent sedimentation and thus aggregation or caking of particles. When agitation is applied, the viscosity is reduced and provide good flow characteristics from the mouth of bottle. Now we are coming to the stability of suspensions. Stability part of the suspension. Physical stability is defined as the condition in which the particles remain uniformly distributed throughout the dispersion without any signs of sedimentation. It is difficult to achieve this condition, hence the definition can be resulted as if the particles settle, they should be easily resuspendable or redispersed by moderate amount of shaking or by mechanical shaking. Therefore, the extent of sedimentation and ease of redispersibility are to be evaluated by appropriate methods. The methods should be simple and easy. Application of Stokes' law is tedious because many parameters are involved in each of them have to be evaluated separately. Okay, the extent of sedimentation is quantitatively expressed by two parameters. They give a gross picture on stability and are normally used for the purpose of comparison of different suspensions. These are applicable to flocculated suspensions only. Pharmaceutical suspensions are thermodynamically unstable system. So they always tend towards the ultimate loss of stability, which one examines at a time is only the apparent stability of product. Stability of suspension can be considered in two ways: physical stability or chemical stability. I have told that physical stability is defined as the condition in which the particles remain uniformly distributed throughout the dispersion without any signs of sedimentation. Particles do not sediment for a specific time period, and if they sediment, do not form hard cake. To achieve this desired target, one must consider the three main factors affecting the physical stability: the particle-particle interaction and its behavior. The process of aggregation will accelerate the sedimentation and affect the redispersibility. For this, the potential energy curves may be used to explain the sedimentation behavior, which generally is indicative of an interaction of two charged surface which gives rise to two types of suspension systems. Therefore, like deflocculated and flocculated. Physical stability is defined as a condition in which particles remains uniformly distributed throughout the dispersion without any signs of sedimentation. The extent of sedimentation is quantitatively expressed by two parameters. These are applicable for flocculated suspensions only, that is sedimentation volume and degree of flocculation. Sedimentation volume is defined as this sedimentation volume denoted by the capital F. So it is defined as F equals to VU by V0. VU is ultimate volume of the sediment and V0 is initial volume of the suspension or the original volume of suspension before settling. Though F is denoted as the sedimentation volume, it is a dimensionless number. Sometimes F is represented as Vs and is expressed as a percentage. Similarly, when measuring cylinder is used to measure the volume can be written as HU divided by H0, where HU represents the final or ultimate height of the sediment. The height of the sediment, final, final height of the sediment, and H0, which is the original height of the suspension before settling. Okay, so if that means the sedimentation volume can assume a value of 1 when there is no sedimentation, VU equals to V0, which is desirable property of an ideal suspension. Okay, if can also assume 0 value when sedimentation is complete, VU equals to 0. That means the no sedimentation, indicating the total instability. Normally, F value is between these limits 0 to 1. In general, higher the sedimentation volume, better the physical stability. Please note this thing. Higher the sedimentation volume, the better the physical stability. Sedimentation volume method is used as one of the common basic quality control tools because it is simple and easy to estimate. Okay, so sedimentation volume defined as what? F equals to VU divided by V0, where VU is the ultimate volume of sediment and V0 is the initial volume of suspension. Okay, so also represented as HU by H0, which is denoted by the height. When sedimentation is F can also assume when zero value. When sedimentation is complete, VU equals to 0, indicating total instability. VU, that means the ultimate volume of sediment. Normally, F value is between these limits like 0 to 1. In general, the higher the sedimentation volume, better the physical stability. Sedimentation volume method is used one of the common basic quality control tools because it is simple and easy to estimate. This method is good because the system remains indestructible, undestructive, and the experimental procedure follows the model of kinetic study. A series of suspension can be prepared using different suspending agents or varying concentration of same suspending agents. These formulations are transferred into 100 ml measuring cylinders at different time of intervals. The sedimentation level in ml is measured. A plot is drawn by taking time on x-axis and VU divided by V0 on y-axis. At 0 time, the ratio is equal to 1 as VU equals to V0. At the time it elapses, the sedimentation levels decrease. Then the curve moves downward to the right of the time axis and goes on After some time, the F value remains more or less constant. This is indicated by the parallel line to the x-axis. Comparison of such curves permits the selection of better suspensions. Ideally, F value should be equal to 1, but simple guiding principle is that the higher the F value, the better the product. This method can be used to select better suspensions, identify a suitable suspending agents, obtain optimum concentration of suspending agents. Here the degree, uh, sorry, sedimentation volume F is an important screening procedure through it is not an absolute evaluation. Next is degree of flocculation. It is defined as very first it is denoted by the beta. So it is defined as beta equals to capital F divided by capital F alpha. Capital F is represent as sedimentation volume of flocculated system, and F capital F alpha is represent as a sedimentation volume of deflocculated system, or beta equals to VU by V alpha, where VU is ultimate sediment volume of the flocculated system and V alpha ultimate sediment volume of deflocculated system. In both situations,